Okay, these are the notes for 5-3 linear relationships and bivariate data. So the first directions say, does each of the tables represent a linear relationship? Explain why or why not. So you have to know that linear just means it's going to be a straight line. So I could, if I had a graph that these coordinates would fit on, I could graph them, but these are really big numbers, so I can't, it's not really easy for me to go graph these somewhere. So what I need to do is see if it has a constant rate of change. So I'm going to be finding the change in y, put it over the change in x to see if there's a constant for that change, or if it has a constant slope. That means the slope would be staying the same, and that would be a straight line. So the x's are on the top, the y's are on the bottom. So I'm going to start finding their changes. So it went from 220 to 240. It added 20. And then for the next one, it added 20 again. So since the same thing happened, as long as it does like the same increments on the top, then I know it's going to be the same. So the first set of x's right here added 1, and then they added 1 again. So if I take this first change in y values and I put it over its corresponding, so straight up above it, change in x values, I get 20 over 1, which simplifies to just 20. I don't need to set up the next one because they said the same thing. It would be 20 over 1. So it has this constant rate of change or a constant slope. So since it has a constant slope, both of them simplify down to 20, I do know that it is linear. Because the table showed a constant rate of change. Number 1 is linear. Number 2, I'm going to check to see if the change in y over the change in x is constant. Because if it's constant, that means it is a straight line. So I have x is on the top, y is on the bottom. So if I look at that first change in y, from an 8 to a 12, it added 4. But then if I go from 12 to 15, it's adding 3. So on the top, change in x, it added 1, and it added 1. So if I set up these two ratios of the change in y over change in x, it's going to say 4 over 1, and then this one over here would say 3 over 1. These two ratios do not simplify to be the same constant. So, since there is not a constant rate of change, it is non-linear. No constant rate of change. Ran out of room, so up here beside number 2, I'm going to answer this is non-linear. Because if I simplify this, that's 4. If I simplify this one, that's 3. That's not a constant number, so the slope was changing. It would not be a straight line. It is non-linear. On number 3, it said write an equation for each linear relationship. Okay, for a graph, I'm just going to continue what they did for their slope in between their points. So to work my way backwards, they were going left 2, down 2, left 2, down 2. So I'm going to do that. It works its way back to the origin. So now you can go ahead and draw the line to connect those points. Since this is linear and it's going through the origin, I know this is proportional. Therefore, I'm going to write an equation in the form of y equals kx. Because proportional has a constant. Okay, so the only thing that I have to find on my graph is the slope, and I'm going to put that in there for the constant. To find slope of a graph, you need to write the ratio rise over run. I can do it between any 2 points. So I'm just going to start from the origin. So rise and run, it was counting by 8s over here. So since I started at 0, I can easily see that the rise was 16 because that's how far it went up to. So I'm going to put that for the top. My run, this axis down here, horizontal x-axis, is counting by 2s. So whenever I do my run, I'm counting by 2s. 2, 4. Remember that you definitely want to simplify slope. So 16 divided by 4, I'm just going to get the integer 4. So I'll write it down here on this line. Y equals 4x is the equation that represents that graph. Okay, yesterday we practiced this a lot where we were going to stat and inputting the data from the table into list 1 and list 2. So you need to hit stat and then edit. So just choose enter. Remember, if there's numbers in there, you hit clear enter. Okay, so we're going to do 1, 2, make sure you're doing this on your calculator. It goes 1, 2, 4, and then 6 if you're looking at the table right here. Remember that those X's are going to go in list 1 and the Y's are going to go in list 2. We just had to hit the stat and then edit to get there. Okay, over in L2, I'm going to enter 10, 12, 16, and 20. So after you have entered your data into list 1 and list 2, you hit stat, calc, 4, and then enter about 5 times until it writes the equation for you. Okay, so stat over to calc the number 4 because it said linear regression. So it's going to calculate, remember where they said A, that's just going to be our M. So it's telling me to put a 2 in front of the X for my slope, and B is our y-intercept, so that 8 is going to go at the back. So for our answer, y equals 2x plus 8 is the equation that fits this table.